Hey guys, it's David from 3D Make It, and today we are going to be talking about closed loop stepper drivers. Let's go. So before we get too far into closed loop stepper drivers, I have to send a shout out to our patron, Stig. Thank you for sponsoring this video and sending these stepper drivers to us. So this video is in effect sponsored, but not by the company that we are going to be talking about. Thank you again, Stig. And while we're on the topic of Patreons, thank you guys so much for being our Patreon supporters. Helge, thank you for being a tree supporter, and everybody else on this list, you are amazing. If you guys are interested in checking us out at Patreon, it's patreon.com/3dmakeit. So today we are going to be talking closed loop stepper drivers, what they are, what they do, and do they belong on your 3D printer or maybe any 3D printer. The stepper drivers that we're going to be talking about today are from BigTreeTech. They're the S42B V2. There's two versions of this, version 1 and 2. They're very similar. V2 has a few more options on it, and it also has a CAN bus for other outputs so you can monitor it. But we're going to talk about the V2 today, but keep in mind both of them are similar. So I guess we should define what the heck is a closed loop stepper driver or an open loop stepper driver. And right now, 90% of us are running open loop printers. So we're running open loop printers like the Ender 3, a CR10. Basically what that means is you're sending signals to your printer and it's just doing it. There's no response. There's no call back from the printer going, hey, yeah, I'm okay. So in layman's term, you got to think networking a little bit. In my world, the TCP IP, you send a packet and it comes back and says, I got it. That's a closed loop system versus our stepper drivers now, which are open loop, which is more like video packets from the internet. They just send them to you and hope you get them and it doesn't get garbled up and you don't get to validate them. So the advantages of a closed loop system are that it provides feedback, i.e., if your stepper motor skips a step, it'll say, whoa, you skipped a step, and it will try to print where it left off and repeat that step. Now, the way it does it is kind of cool. But let's jump in and look at the SB42 and exactly what we get with it. So here we can see what we get in the package. Now, this SB42 package that I got was the one that was specifically designed for the Ender 3 Pro or very similar frame. Now, the Ender 3 has those wheels underneath, and the reason this is the kit for that is it comes with a new wheel, because if you don't put the new wheel on, it will collide with the stepper driver. So, but we can see here that the stepper driver comes with the wheel, a screen. It comes with the driver module, so you can actually plug it into the board. It comes with spacers that are actually spaced at a proper distance and you have to use them. It comes with the pigtail cable to plug from the motor to the stepper driver and from the stepper driver to your controller. So the long white one goes back to your controller and the short pigtail kind of wraps around and plugs into your stepper motor. And then it comes with some screws and some magnets. So we'll go into kind of an overview of the installation here in a second, but spoiler alert, the screws, you get a short one and a long one, and the long one was too long and the short one was too short, so I made the long one shorter. But let's jump into the install process, which is super easy. So I did do a bit of a live stream on the full install, but the steps for installing this are really easy. So step 1 is you get a little magnet in the bag with the screws, and that magnet has to get glued to the bottom of your stepper motor in the little space. Now, the reason for that is there's an encoder on the stepper driver itself that it sits above that magnet, and basically while the magnet rotates, it knows everything's okay. And so the encoder is counting those magnetic pulses, and if it stops, it knows that it's missed a step. So you have to glue the magnet to your stepper motor or nothing's going to happen. So get some tweezers out, a little bit of super glue, make sure you get it right in the center like in the picture here, you're golden. The next step is really, really easy. You're going to put the 4 screws into the bottom of your stepper motor, and you're going to add the stepper to it. Now, you're going to have to take out the screws that were there, and this is where the screws that were too long for me or too short, so I had to cut them a bit so that the thread would bite in the motor. And you do have to use the spacers between the stepper driver and the motor. It is really simple to do, and again, I did it on a live stream. I'll leave the link in the video here, and you can kind of see what we did. Now, the last step really is plug everything in. And so the little pigtail plugs in and around the stepper driver. And then the other one, the long white one, will go back to your control board and kind of plug in like this. So using this kind of stepper driver precludes you from using any board that doesn't have dip drivers. So you have to be able to plug a driver into your board. So any of you regular Creality board users out there, or even like the E3 Turbo and the Mini E3, you will have to get a board that accepts those dips. You can use any kind of dip board and it will work. Now, the next step is, once we got all this stuff installed, we're going to need to do a little bit of work on the firmware. So let's jump over and look at the firmware requirements here. So it's important to note that the closed loop stepper actually has its own controller. It's an STM32F103CBT6. That's a mouthful, I know. No, I did not memorize it. It also has A4950 drivers versus the normal drivers on the old boards that were A4988 on the other Ender boards and the older drivers that we use. And it also has an encoder. And if you're interested, the encoder part number is TLE5012B. So that's the thing that's actually counting the pulses. So since we're using an Allegro driver, so the A4950, in our firmware, we're actually just going to tell the firmware that we're using A4988s. So if you haven't defined any drivers, congratulations, that's the default if you don't define them. If you want to put a definition in there, you can put A4988. Now that's the first step. So the other place in Marlin you might have to look is in your configuration.advanced file. Now, these stepper drivers, if you hook them up and they don't actually move, which happened to me, oddly enough, it only happened on one axis. So the X was moving fine, but the Y wasn't moving so good. You have to go into that configuration.advanced and you define minimum stepper pulses, and you define it as 3. And then you define the maximum stepper rate, and that's 150,000. Once you do that, it does actually move. Now, when these first came out, there was a bit of an instruction that said, this is only for Core XY in Marlin, and that doesn't make a lot of sense when you think about what it's actually doing. If it's going to affect any stepper drivers, basically it should affect all of the configurations, and it does. So I had to do this. So just make sure you take the time, go through Marlin, you change the stepper drivers, and then you just define these 2 settings. So now everything is done in the firmware. You can plug your stepper motor into the board. We're ready to power it on. There's a few things you're going to have to do before you're absolutely ready to print, and one of them is calibrate this. So the screen actually has 4 buttons on it. The middle one is an enter button. The bottom one kind of scrolls. The top one is enter the sub menu and pick your value, and then you can escape with it, and eventually you can set the values. Now, once you set values, there's a reset button on the bottom, and you have to push that just so like the settings you made, it's no different than actually flashing your EEPROM when you make new changes, just to make sure on your controller. Same thing, just hit that reset and it will set your new settings. Now, one thing you have to do in that menu is calibrate. So when you go into the screen menu, you're going to look for calibrate on it. Before you get to the screen, there are 4 switches underneath the stepper. The 4 switches should be set. Usually the 3rd one is on and the 4th one, when you're calibrating, is on. When you're done calibrating, the 4th one comes off. Now, when you calibrate this, make sure that whatever axis you're calibrating is about in the middle. Now, The reason I say that is if you center your bed or center your X gantry or the Z, whichever one you're doing, it's going to move it 200 times. Now it's not moving at 200 millimeters. It's just moving 200 steps. So you just want to make sure while it's doing this operation that you have enough room to move without actually like grinding belts and stuff. Once it's done, you flip the 4 off and hit reset and the calibration is done. Super easy. The other setting that you'll probably go into, actually there's 2, is you're going to set the motor amperage, and I set mine to 800 milliamps. It worked fine. That's what they recommend. It can go up to 1650, so you have some play. Now, the other thing that you are going to set and you will have to check out is the micro stepping. And I want to talk about this for a second. Let's listen to this lovely sound. So yeah, your motors are going to be a little louder again. It's an awful like owning an A4988. They aren't that silent. Now, when you're stepping or micro stepping, 16 is usually default, but you can go up to 32. I went 32 because it got quieter. The higher steps you use, for some reason on this stepper driver, it got quieter, which on other ones I've seen it get louder. But when you do change your micro stepping, remember you're going to have to change your E steps per axis. Now, the nice part is you can use some quick math just to do it quick and dirty and see how it works out. So if you were printing at 16 micro steps before and all of your steps on your printer were working and you changed to 32, you can just double the number in your steps and away you go. So roughly if you're looking at an Ender 3, you're usually 80 steps for your E steps there. So you could go up and you could say 160 if you're at 32. So that's just quick math. I mean, if you print something after that and it's a bit wrong, you can calibrate it. Again, once you get your E steps in there, print a cube, print a benchy, measure it, make sure it looks okay. If you have a pressure calibrator, you can use those too. I used a pair of calipers on the side and just kind of bumped it in. So that's kind of the skinny with the setup. There's not a whole lot more that you need to do to get printing. Now, I'm going to talk a little bit about print results, and I'm going to go into kind of like what my testing mentality was and show you some of the prints. So my testing for this was fairly straightforward. I printed 4 benchies. I printed 2 benchies on a 2208 and 2 benchies on this closed loop stepper. Now, I printed one at 80 millimeters per second. I wanted to kind of go, you know, at a faster end-ish on an ender just to kind of see how it looked like at an okay quality. And then I printed another one at 150. I chose 150 just because it's a little bit faster. It gets into that range where it is faster. And I'm going to say that the TMC 2208s did just fine. There was nothing really to write home about. And, well, let's just look at these results. So this guy right here is the closed loop stepper one. And he's okay. A lot of the old artifact stuff that came out when, like, the reason we were using, like, smoothers and all that stuff is back. There's ghosting on the windows. There's lines, there's artifacts above the door, and you know, right above here you can see like extrusion lines. It's not the best, but it's not the worst either. So I'm going to say acceptable, but it introduces some stuff that we in theory had gotten rid of. So okay at 80. Now the TMC version is much better. There's very little, if any, problems with it. It does have the benchy line on the hull there, and that's actually due to a damage in the model itself. The digital file is missing that section, so unless you repair it, it's going to do that. Other than this benchy is lovely. It printed great. I really have no issues with how it looks. It's a green benchy. So the next test I did is going to be the 150 millimeters. Now, the 150 was an interesting test because obviously on a stock ender, your cooling won't keep up as you get higher into your print. Now, when we look at the cooling issues on the hull here, that happened on both of them. So the little mush at the front there, that's just something that's there. Now, this is the TMC 2208, and you know what? It looks pretty good. It's not terrible. Again, 150, so there's a little sagging, but it has the same lines, and I can live with that quality. Now, as we got higher in the closed loop stepper, you can see, other than the same artifacts that were there in the other one, the cooling was off. So speed-wise, they both performed fairly well at 150 millimeters per second. So here I'm printing a rocket. It's the G-Create rocket in vase mode, and thank you to my wife for holding the camera because I didn't have enough hands. Now, this rocket in particular, it wasn't super fast. It was 80 millimeters a second. Now, the idea behind these closed loop steppers is when they skip a step, they will readjust and bring your print back into it. So here you can see it's skipping a step a lot. And here's the result. Let me show you what happened to that print. Yep. It worked fantastically, except for the fact that it didn't do any correction at all. And I do have the reason for that, and probably some of you watching the video have the reason for that now and are screaming it. So this is what that print looked like. So other than the fact that it's garbled, layer shifting craziness, like the print was looking actually really good. So print quality in these steppers isn't bad. You just got to make sure that when you are setting them up, you get your micro stepping where you want them, and then calibrate those E-steps. Now, let me get to my thoughts on these closed loop steppers and wrap the video up. So that's the S42B. Now, what are my thoughts and what the heck happened? So first off, the benchies, the speed, all of that was great. I think if you're looking for speed, there's better options, and I'll get there. Now, what happened to that rocket? Why did it shift so terribly? And the reason is because of that magnet. So the magnet is sitting on the bottom of the motor, like in this picture, and that's how the encoder pulse reader is gathering data. So why did that rocket shift so bad? Well, when I shifted it and pushed it or pulled it, it didn't skip the driver shaft. It actually skipped the belt. So therein lies the problem with the S42 and other similar-ish closed loop drivers that use the magnetic encoder, is you need a skip on the actual motor itself. So if you have a system that has ball screws for driving up, back, and forward, that would work perfectly, because the torque on the screw would skip the motor, and then it'd be like, whoa. If you have rigid frames and you're using high wind rails and lead screws, that would also skip the motor. If you're using belts, well, the belt will skip on the pulley probably before it skips the motor, and that's exactly what happened in this case. The belt skipped, but the motor did not, and it didn't know that it had skipped. So even though we were using a closed loop stepper, it didn't actually get the input it needed to correct the issue that was on the printer. And that's really my final, I guess, thoughts on this product. It's a great product. If your goal is to print faster, I probably wouldn't go this route. I might use like a 5160 with like a lot of torque and a heck of a lot more amperage, and then you can push your printer. Now, this particular driver has been used-ish, and the technology for closed loop has been in CNC for a long time. And frankly, that's where these drivers are going to go. They're going to go on my CNC 3018, and that's going to be a good home for them, because that's where it can correct. 3D printers just don't offer a lot of resistance while they're moving, so the chances of you skipping a step, and this is why open loops work for 3D printers, if you're not colliding with anything and there's no pressure, run a very low risk of skipping steps if you keep your machine tuned up, belts tight, wheels happy, all of that stuff. Now, on a CNC, where these, in my opinion, probably belong, you do have pressure. You have a router and a mill that pushes into wood and goes back and forth and causes pressure, and that can lead to skip steps if you hit a knot in the wood, right? Or it's just if the machine comes up against a little bit of a hard corner, it can actually kick back and you result in skip steps. And that's where something like this closed loop stepper, because the 3018, like I said previously here, runs on ball screws, which can provide that back pressure to the motor and then give the feedback to the closed loop steppers. So final thoughts. Is it something that I would run out for speed and buy on my 3D printer? No. Is it something that I would add to my 3D printer to increase quality? No. Is it something that you need on your 3D printer to improve something? Probably not. But it does have a place in making and especially milling. It's not bad technology. It's just one of those things that if you want to go faster, yeah, maybe just invest in some 5160s with some higher amperage and torque. Or again, like you can tune your printer with 2209s or similar to actually start printing faster. And on the quality front, the prints, they looked okay. There would be some tuning again and finessing and getting those artifacts out of the print that we got out with the TMC drivers. So it's something that just introduces artifacts again that we had licked. And so from that standpoint, it's not going to add quality to your prints. And I think we saw that in the benchies. So there you have it. That's our thoughts on the closed loop stepper. It's a cool piece of technology, but not a needed addition for a 3D printer. If you guys made it this far, you are awesome. Hey, did you know we have a podcast? Just check out 3D Make It on any of your podcasting apps, and you can follow along where we talk about things like closed loop steppers and new boards. So until next time, hit that subscribe, hit the like, share us around, and you guys have a good one.